Hello students, welcome back. In the last session, we have studied exceptions in Java. We had started with a new chapter, that is exception handling or managing exceptions in Java. In that we have first studied the types of errors, that is compile time error and runtime errors. Then we have studied what is exception, which is a condition that causes a runtime error, that is caused by the runtime error in the program. Then we have studied the hierarchy of Java exception classes. At the top of the hierarchy we have a class called as throwable, which is inherited by two important classes, the class exception and error. Okay, which is again inherited by some other classes. It also contains some subclasses. Then we have studied types of Java exception, which have been classified as checked exception, unchecked exception and error. So that we have studied in the last class. In today's class we will continue our discussion of exception. So let's start. Okay, we'll start with common Java exceptions. So this figure below displays list of common Java exception. So common Java exceptions are arithmetic exception. Now this exception, it is caused by math errors such as division by 0. In a program, in a Java program, if you have a statement which divides a number by 0, in such cases arithmetic exception may occur. So this is caused by mathematical errors, such as one of such error it is division by 0. For example, if I have a statement in the program like A divided by B, where B is equals to 0, where B is equals to 0. Such statements in the program may generate or may cause arithmetic exception. Okay, then we have exception, that is array index out of bounds exception. When this exception occurs, array index out of bound exception occurs, or it is caused by bad array indexes. This simply means if you are trying to access an index, array index which does not exist, in such cases array index out of bounds exception will occur. For example, if we have an array, say we have an array A is equals to say 5, this is 5, A is equals to A of 5, or we have an array with 5 elements, and if I try to access an array, if I try to print an array position, that is if I say SOP, that is system.out.print SOP, and if I try to print a value that is A of say 6, A of 6, do we have value at A of 6 in the array? The answer is no, because our array size, if you look at, the array size is 5. When we have array size 5, the maximum index value which we have, it is 4, because index always starts with 0. And if you try to access an index which does not exist, in such cases array index out of bound exception occurs. Okay. Then we have array store exception. The next exception, it is array store exception. Now this array store exception, it is caused when a program tries to store wrong type of data in an array. whenever you try to store a wrong type of data. Whenever we declare a array it is declared with a type. Say we declare an array of integer, that is int a of 10 or a of 5. That means that particular array can store only integers. But if you try to store some other type into it, then it will cause an exception, that is array store exception. Okay. Then we have the exception that is file not found exception. Now when this error occurs, this is caused by an attempt to access non-existing file. Means from your program you are trying to open an external file, but the name which you have specified for the file, that does not exist. I am writing a Java program which accesses a file from the system, or it reads some data from the system's file, but I am trying to access that file, but the file does not exist. In such cases, file not found exception occurs. Okay, then we have IO exception. This is caused by general IO failures such as inability to read from a file. Now IO exception occurs whenever you try to read or write from a file or some other sources or destinations. If you are, suppose you are trying to read from a file and something goes wrong, it will cause IO exception, which simply means input output exception. If you are trying to trying to write to a file or write to some other device, and if something goes wrong, it will generate IO exception. Then we have null pointer exception. This is caused by referring a null object. Null pointer exception occurs when you try to access an object which is having value null. You are trying to access an object, but the object is having value null. In such cases, null pointer exception will occur. Then numbered format exception. This is caused when conversion between string and numbers fail. Whenever you convert string to number, and if that conversion fails, then number format exception will occur. For example, if I want to convert a string to integer, to convert string to integer, we use a method that is integer.parseInt, right? We use integer.parseInt to convert string to integer, and if that conversion fails, it will throw number format exception. Now look at the number. Suppose I have a number that is 10. Now this 10, it is enclosed in double quotes, remember? Okay, enclosed in double quotes, that simply means this is a string. And if I try to convert this 10, which is in string format, into number, I may use a function that is integer dot parseInt. Okay, parseInt, and I will pass that value 10 to it, and this will convert this 10 into integer form, and that may return a value 10 without double quotes, means this is a integer number. Now this conversion occurs or happens successfully. This 10 can be converted into integer successfully. Suppose, but if you have a string that is say ABC, and if you are trying to convert this ABC into integer, can you able to convert ABC into integer? The answer is no. These are characters, or this is a string which cannot be converted to a number. In such cases, number format exception will occur. Okay, so that is number format exception. Next is out of memory exception. As the name suggests, out of memory is caused when there is not enough memory to allocate a new object. When the memory is full, it will cause out of memory exception. Then we have security exception, and the security exception, it is caused by when an applet tries to perform an action not allowed by the browser security setting. Applets are also Java programs, small Java programs which are executed on the internet or browser, and when these applets tries to access or tries to perform some actions on the machine which are not allowed, then it will cause security exception. Applets are not allowed to read and write to a local file system, but if applet tries to read and write from a local file system, it may generate a security exception. Then we have an exception that is stack overflow, caused when the system runs out of stack space. There is also one more memory space that is called as stack memory space, and when the stack memory space is full, it will generate an exception that is stack overflow exception. Then we have string index out of bounds exception. Like we have array index, even a string has an index value, and if you try to access a character from a string which does not exist, in such cases it will generate string index out of bounds exception. Okay, these are some common exception or exception classes which are available in Java. There are many other exception classes available. Okay, next is syntax of exception handling. Now the basic concept of exception handling are throwing an exception and catching it. So the basic concept simply includes throwing an exception. If the exception occurs, it is thrown and that needs to be caught and handled. Now this diagrams explains how we can write exception handling code. So we have two important blocks, that is try block and catch block. Now try block generally includes statements that may cause exception. It includes statement that may cause exception, and when there is a exception in the statement, that exception is thrown, exception object is thrown, and that is caught by a catch block. So exception object created, the statements which creates an exception object. The interpreter generally creates an exception object when the exception occurs, and that is thrown and that is caught by catch block. And catch block also includes some statements which are used to handle the exception. So some actions are performed to handle the exception, that is included in the catch block. So catch block, it is called as exception handler. So this is how we can handle exceptions in Java. The programming code for exception handling is given here. You can see on the right hand side. We have try. The keyword try is used for handling exception. So try block generally includes statement which may generate exception. So we have try, open bracket of try, and we have a close bracket of try. So in between the open and close bracket of try, we have some statements, and we include these statements which may generate exception. So you have to include such a statements inside this which may generate an exception. Like if you are performing a division of two numbers, then you have to include the division of two numbers inside the try block, because division of two number may generate an exception when the second number is 0, remember. Or if you are trying to read from a file, or if you are trying to read from a user, there is again a chance of exception. If you are trying to read from a file and suddenly something goes wrong with the file, you cannot read from a file. In such cases also there is a chance of exception. So such code needs to be included in the try block. Okay, so this is a try block. Then we also have a catch. Every try, it is followed by a catch block. Remember, at the closing of a try, you have to include at least one catch block. So at the closing of try, we have a catch block, and catch block defines the type of exception it can handle. So exception type E. And if this code which is included in the try block generates the exception type which is equals to the exception type which is defined in the catch block, the catch block is executed and the statement inside the catch blocks are executed. The statements usually used to process the exception or to handle the exception. Okay, so this is the basic syntax of exception handling. Next, let us look at one example which is used to handle exceptions. Okay, so this is the program illustrates the use of try and catch block to handle arithmetic exception. To handle arithmetic exception, we use try and catch blocks in this program. Now we have a class, then the main function. Inside the main function, we have defined certain variables. See, variable declaration, it is not included in the try block because this is straightforward, that may not generate any exception here, declaring a variable. So that code is not included in the try block. So variables have been declared, and then we have started with a try block, bracket open and bracket close, and inside the try block we have a statement, one statement we have that performs division of two numbers. So A is divided by B minus C. And this statement, not always it generates an exception. Again, it depends. It depends on the value of the second part, that is B minus C. So we need to include this statement inside the try and catch block. And how the catch block is defined? Catch arithmetic exception, exception E. And if the arithmetic exception occurs, we are displaying system.out.println, we are displaying a message saying division by 0. Okay, and after that we have some, after catch we have statement y is equals to A, actually this is divided by, so this I is not present, A divided by B plus C, and we are printing the value of y. Okay, so if the exception occurs, the try and catch block or the catch block handles the exception and program execution still continues, remember. If you are not using an exception handling code and if an exception occurs, the program execution stops at that point. It will not continue further. But the advantage of using exception handling is that your program still can continue execution even with the exception. So when an exception occurs, exception is handled and the code after the exception handling part is executed. Now this example, if you look at the values of A, B and C, A is 10, B is 5 and C is 5. So this equation will become 10 divided by, that is B minus C means 5 minus 5, and 5 minus 5 it is 0. As 5 minus 5 it is 0, the equation will become 10 divided by 0, and 10 divided by 0, as you know, division by 0 error or exception occurs. So that comes under arithmetic exception. So one object of arithmetic exception is created at this point, arithmetic exception by your interpreter, and this object is thrown, and when it is thrown, it goes to the catch statement. First is catch statement. Again, this object name arithmetic exception, it is compared with the exception which is declared in the catch block, and if it matches, here in this case it matches arithmetic exception, then the handling part is executed. And after the handling part is executed, the code still continues execution, means after that the code which is here, that is y is equals to A divided by B plus C, is executed, and it will also print the value of y, means program will not stop at that point, program still continues execution. Suppose at this point some other error occurs, if it is not arithmetic exception, remember, if some other exception occurs, that is also thrown, but there is no catch block to handle that exception, because we have one catch block which handles only arithmetic exception. In that case, if there is no handling part, the program terminates at that point. Okay, let me execute and show it to you. Okay, this is our program. I have already copied and pasted it here. Okay, so let me compile and execute it. Okay, to compile we have to open CMD. then we need to move to a folder where we have saved our program. Our program is saved in F drive. So I'll first need to go to F by using F:, then I am in F drive. I can compile it here. Javac program name is error3.java. There are some errors in the program. Those errors we need to remove first. These are compile time errors, remember, these are not exceptions. So the error, you can see there are some unrecognized characters before this division by 0. So those characters we need to remove. So the characters are double quotes, I think. So we need to change the double quotes. Okay, let's try again. Okay, the program compiled. Let us try to execute it by using a command java space file name, and you can see it is displaying an error division by 0 because we are trying to divide number 10 by 0. So it throws an exception, it goes to this line where it displays the message division by 0, and program still continues, and that is the reason we are getting the value of y here, why it is printed as 1, because program still continues, it will not stop at that point. Okay, if I change the value of b, say if I make it as 10, and if I again compile and execute, now you can see there is no exception. There is no exception. The program continues execution. It is in a proper way, in a regular way it continues its execution and it displays the result. There is no exception. Now you may say it is still printing only the value of y because we haven't printed the value of x here. If we would have printed the value of x, then we would have even got that. Okay, let me print it here. I'll say x is equals to, okay, let us compile, execute. You can see x is 2, y is 0. Okay, so this is how we can handle exceptions in Java. Okay, next, multiple catch statements. It is possible to have more than one catch statement in the catch block as it is illustrated in this example program. So whenever we include some statement inside a try block, it is not always that statements which have been included in the try block will generate a single type of exception. The statements included in the try block may generate multiple different types of exception. So it is important to handle all of those different types of exceptions separately. So if a block of statement generates some 3 exceptions, these 3 exceptions need to be handled separately, and that is the reason we can have multiple catch blocks in the program. So for a single try block we can have multiple different catch statements, and the format of defining multiple catch, it is given in this example. So we have try, open and close, then we have some set of statements here, and this set of statements may generate multiple different exceptions, and that is the reason we have included catch 1, which defines one type of exception and it has a handling part. So catch 1 is open, catch 1 is close. After closing we have one more catch and it has to be continuous, remember, catch statements, and this defines a second type of exception. We have one more catch which defines a next type of exception, and so on. Any number of catch statements can be defined, and each of this catch statement may handle a different type of exception. So if the statements inside a try block generates one type of exception, say arithmetic, it will go for the catch statements which handles arithmetic exception. If it generates array index out of bound exception, it will search for a catch statement which handles array index out of bound exception. So like this, it will handle the exception. So it is possible to include multiple catch statements for a single try block. Next important thing, it is using finally statements. Now, like the catch block, Java also defines one more block of statement. That block is called as finally block or finally statement. Now, finally statement can also be used to handle an exception that is not caught by any of the previous catch statement. If no catch statement can handle the exception, we can handle that exception by using a finally block. It is a block of statement which are executed at the end of the program. Now, finally block, one more important thing about finally block is that it defines some block of statements which are usually executed, or these are executed at the end of a program, and it ensures. Now, this finally block can be used to ensure that all the cleanup work is taken care when the program, when an exception occurs. So, finally block is useful to clean up things in the program, because this is the block which is executed at the end of a program, and it is guaranteed to run whether or not exception occurs. So, if program executes properly, then only the finally block is executed. Even when there is an exception, the finally block is executed. Now, that is demonstrated in this diagram. You can see we have a try block which includes some set of statements. If try blocks generates an exception, then it will go to exception block, that is catch block is executed, and after executing the catch block, lastly it will execute the finally block. Suppose if try block do not generate an exception, no exception, in that case it will not execute the catch block, but at the end it will execute the finally block. So, finally block is going to be executed whether or not the exception occurs. Okay, this is about finally block in or finally statement in Java. So, with this we will stop in today's session. We will continue with the exception handling in the next session as well. Thank you.